Right, here are some selected homework from 4.2c. So in this video, I hope to go over 49, 51, and 53 on page 269. Right. So these problems we're trying to use the limit process to find the exact area of the region. So we want to use a limit definition, okay, which is width f left plus width times I. So we have our function for 49, y equals x squared plus 2. The x intervals from 0 to 1. So our width formula is b minus a over n. So simply 1 minus 0 over n, so 1 over n. So to plug into the formula, we have width, which is 1 over n. F left, my left endpoint is 0, plus width times I. So plus width, which we found to be 1 over n, times I. Okay, so now next step, we want to get this out of function notation. So we're going to plug all this into the x of our function. Okay, so all this will get plugged into this x value. So now 0 can just go away. So this makes it a little bit simpler. We can rewrite it as f of 1 over n times I. So we're simply plugging 1 over ni into the x. So that'll get us x, which is I over n squared plus 2. Okay? We've gotten it out of function notation, so now we can try to combine this together. We're going to distribute the 1 over n through. We get I squared over n cubed plus 2 over n. And now we can split this up into smaller portions and try to isolate the parts that we're going to be applying the summation formulas for. So n, remember n is a constant. We can pull this in front. So 1 over n cubed, summation from 1 to n for I squared. We do have a rule for this. Okay. And then 2 over n, we can pull this out and have the sum from 1 to n for constant 1. So we have a rule for this as well. So summation for from 1 to n for I squared gets replaced with n cubed plus over 3 plus n squared over 2 plus n over 6. And the summation from 1 to n of a constant 1 gets replaced with n. So now we have everything in terms of n. Distribute everything through to get rid of the parentheses, and then we can evaluate the limit as n approaches infinity. So distribute everything through, and we see that these two fractions are going to go to 0 because the denominator's degree is higher. So the only coefficients that we're going to keep is the first 1/3 and the second one 2 over 1. So 1/3 plus 2 is 7/3. Okay, 51, much the same way. We have our function, we have our a and b values, we find the width, b minus a over n, which is 2 over n, and we plug into our formula. Okay. Width f left plus width times I. Okay. Left endpoint is 1, again the width is 2 over n times I. Next step, get this out of function notation. So we're going to plug all this into the x value here. Okay. So if we plug this into the x value for the function, we're going to be left with 16 minus x squared. And x gets replaced with 1 plus 2 over ni, quantity squared. Okay, so now we have to do some work here to get this out of, get the parentheses away, and also to deal with this exponent here. So we can write this out twice, full this out, 1 plus 4i over n plus 4 over n squared I squared. Distribute the negative through, and I'm also going to be combining 16 minus 1, which is 15, okay, minus 4i over n, minus 4i squared over n squared. And finally, don't forget the width. We're going to distribute that through as well. So I just get 30n minus 8i over n squared minus 8i squared over n cubed. Okay, so once I have that, then I can split this up into individual portions and try to isolate the parts that we're going to apply the summation formula. So I can pull the 30 over n out, pull the 8 over n squared out, and then pull the 8 over n cubed out, leaving me with summation of 1, summation of I, and summation of I squared. Okay, we have rules for all these, so we make our substitutions, distribute through, and get rid of the parentheses, and see which portions go to 0 and which ones we're going to keep. So for these three fractions, we're going to they're going to go to 0 because the denominator degree is higher, because n is approaching infinity. So we're left with 30 over 1, which is 30, 8 over 2, which is 4, and then 8/3. So we combine this, we get 70 over 3. Okay. Let's also over 53. So we have y is equal to 64 minus x cubed between the intervals from 1 to 4, so our width is going to be b minus a over n, 4 minus 1 over n, which is 3 over n. Okay, we plug into our formula. Okay, width f left plus width times I, so my left endpoint is 1 plus width times I, 3 over n times I. So get this out of function notation, plug all this in for the x, so we're left with 64 minus x cubed. Okay. Now we have a binomial cubed, and it's a little messier to expand this, but we can use Pascal's triangle. Okay, if I have a plus b quantity cubed, my leading coefficients will be 1, 3, 3, and 1, and my variables and exponents are going to be decreasing, starting a cubed to a squared to a to the 0, and then my second variable is going to start at b sub 0, b to the 0, b to the first, b squared, and b cubed. So this is going to be the expanded form for a plus b quantity cubed. So the same thing, I can treat this like my a value, I can treat this like my b value. So if I want to expand all this, I can write this as 1, okay, because 1 is a cubed. 3 is my leading coefficient, so 3a squared, and a squared is simply just going to be 1 squared times b. My b value is 3 over ni, 3i over n, and plus 3ab squared, so 3a. Now I'm leaving the a out because a is simply 1, so it's not going to make any difference. B squared plus b cubed, so b cubed is 3 over ni cubed. Right, so it's a bit messy to simplify, but we can just multiply all this through and distribute the negative through. So 64 minus 1 is 63. Combine all this, we get 9i over n. Here we get 9 squared over n squared times 3, which is 27 over n squared. And here 3 cubed, n cubed, I cubed. So we have this value here. Okay, distribute the 3 over n through to each term, and then we can split them up into portions where we can get it ready to substitute in our summation formula rules, or our summation formulas. So summation from 1 over n for I, for 1 we get n, summation of I we get n squared over 2 plus n over 2, summation of I squared, we have a rule for that, and then summation for I cubed, we have a rule for that as well. Okay, it's a long problem here. We're just having to distribute everything through and then determine which portions go to 0. Any fractions where the denominator has a higher degree, we're going to drop that out. It's going to go to 0. So we're only going to keep the ones where the variables are matching between numerator and denominator. And for the problems that we're dealing with, our exponent degree should never be greater than a numerator. So you're never going to get a you're never going to get a n cubed over n squared, for instance. Okay, if you get that, then you want to go back to your problem and see the mistake that you made, and see if you can catch, because that's going to be a red flag that somewhere there's a mistake, either something that you didn't copy correctly or something that you forgot to distribute through. Okay, so then we're left with 189 over 1, we're left with 27 over 2, we're left with 81 over 8. and then also left with 81 over 4. Okay, so we're left with 513 over 4, or combine all these terms together, use your calculator, 513 over 4, or 128.25.